Hello guys, Josam here, URK22CS1024, and this is for the lab DevOps, experiment number 6, manage Kubernetes resources using CLI, command line interface. So the main objective of this program is to install all necessary tools like Docker, Minikube, and the kubectl, and then use the kubectl command line tool to manage basic Kubernetes resources like pods, deployments, and services. So we're going to see the tools which is required is a laptop or a desktop with at least 4 GB RAM with internet access. And the operating systems may include Ubuntu or Debian Linux, Mac OS or Windows. And it should also have a basic terminal or a PowerShell familiarity. So we're going to see the industrial relevance and applications here, like the real world applications of this experiment. Cloud native management. Kubernetes enables deployment and orchestration of microservices on cloud platforms like AWS, Azure, and GCP. And if you guys don't know or not, AWS and Azure, they play a crucial part of running the web-based services here. So the services may include like Amazon.com, Netflix, and Hotstar, or YouTube as well. So if any of these servers are facing any issues, means we can't access any content here. And the next relevance is scalability and reliability, as it supports easy scaling and ensures high availability for production workloads. And DevOps integration. It works seamlessly with CI, CD tools like Jenkins and Agro CD for automated deployments, and infrastructure standardization, where it promotes infrastructure as code, IAC, for consistent automation and portable environments. So we already know what is Docker here, as it acts as a containerization platform to package and run the applications. Minikube provides a lightweight single node Kubernetes cluster for local development and experimentation. kubectl is the primary CLI, command line interface tool, for interacting with Kubernetes API to create and view and manage cluster resources. Pods are the basic deployable units in Kubernetes. Each encapsulates one or more containers running an application. So we're going to see here. So deployments here manage the multiple replicas of pods, ensuring high availability and enabling rolling updates and rollbacks. So if by chance, if any application is not running properly after an update, this ensures that it can go back to the previous working state quickly and without causing any major shutdowns. Services node port, where it allows application running inside the cluster to be accessed externally through a stable network endpoint. Scaling demonstrates how horizontal scaling by increasing or decreasing the number of running pods and replicas based on the load. Cluster management involves verifying node status, monitoring workloads, cleaning up resources to maintain cluster stability. And automation and reliability shows how Kubernetes automates and deploys scaling and recovery key principles of cloud native and DevOps workflows. So here you can see the commands which we will be using here and the explanation here. So we're going to see the procedure and setup installation. For first, we have to install Docker Desktop and or Docker engine in Linux, and verify it's working or not by saying Docker /version. And then we have to put kubectl, Kubernetes CLI, on Windows via chocolate D using the command choco install kubernetes-cl. Then if it's installed, we have to check if it's installed by using this command here, kubectl version and /client. Then we have to install and start Minikube. For that, we can use chocolatey again for installing Minikube. And then if Minikube is installed, we can verify it by putting Minikube start /driver equal to Docker. Then we have to check if the cluster status is working or not by saying Minikube status and kubectl get nodes. And then afterwards, we're going to create and manage a pod. So we're going to create this nginx pod.yaml file here. So this is the code which we'll be using here. And then after saving the code, we can apply the configuration to create the pod. Here kubectl apply dash f nginx dash pod.yaml. Then we're going to use the get pods function to check the status. And then to see the detailed information, we can use the describe pod here. And for accessing it, we can see it in our browser by port forwarding. We can put the port dash forward pod nginx pod. This is the port number here, and we can open the localhost and for seeing it. Then after testing, we can delete the pod by using kubectl delete pod nginx dash pod. And for creating and managing a deployment for nginx, we can use this command here: create deployment my nginx dash image is equal to nginx. And for seeing if it's running or not, we can use the get deployments or get pods command here. And for scaling to 3 replicas, we can put scale deployment my nginx where the replicas are 3, and we can check the status if it's there or not. For rolling updates, we can again go here and we can put image deployment slash my nginx is equal to nginx 1.5, and we can see the rollout status here. And if an update fails, we can roll it back by saying putting rollout undo deployment my nginx. We can expose the deployment as a server also by using node port service, and checking the service details also by using get svc. And then we can get the accessible url also by putting this command, and then we can open it and see it in the browser. For removing the servers, we can put kubectl delete svc my nginx and clean up this to so that when the work is done, we can prep up for the next workflow. So we can clean it up by deleting the deployments, as it's easy to start it again. kubectl delete deployment my nginx, kubectl delete svc my nginx, and kube delete all double dash all dash n default. And for stopping the Kubernetes, the minikube, we can use minikube stop and minikube delete. So we can see here how the verification like process is there, if Docker is there or not, kubectl version is there or not, minikube cluster status, and then the verification of the nodes are running or not, like that. We can see the nginx pod creation here, the pod details, and the deployment and scaling. So you can see the things are running or not, like that. We are verifying it there, and the service exposure is done here. And then after everything is executed, we can put the delete file here and it's running it. And we can see two links here. The first one is running through localhost 88, and the another link is running through the IP address. So we can see like in both ends the program worked successfully. So this is the entire experiment, guys. We have successfully installed Docker, kubectl and minikube, and created and managed the pods, and deployed and scaled applications, and deployed a service, and cleaned up the resources safely. Thank you, guys.